So we're going to talk about this, right? We've been talking about caches for 200 minutes. We're going to spend like maybe 20 minutes on why the values that underpin them are sometimes problematic when brought into other spaces. So we'll start here, right? We've talked about average memory access time. So when we access pieces of data from our CPU, right? On average, how long does it take to access them? This is why we built caches in the first place, right? We saw that processor speeds were rapidly increasing, right? And the average memory access time wasn't, right? Processor speeds are like this, right? Nice steep cliff, right? AMAT is like the floor, right? Absolutely nothing. So we built caches to optimize along this metric, right? This is a metric, right? This is a way of measuring like a thing that we want to work towards, the thing we want to optimize, right? But it isn't the only metric we could have chosen. And there's a tendency in computer science, right, to care a lot about performance and care a lot about efficiency, right? And you may have experienced that in this course. You may have experienced it in other courses, right? We can talk about performance efficiency. It's energy efficiency if you want to be a comp arc, person. But like it's been everywhere in this course, right? We've got cycles per instruction in this course, right? Like that's more comp arc level. We've got how long does it take to run a given program, right? We've got like energy efficiency. So when we're running a given program, what performance do we get for how much power we're burning, right? What else? How many bytes does our program space take up? How many bytes are we using in memory for the data that we're storing and we're wrangling on, right? And then you probably talked about big O complexity in 143. I didn't take 143 here, yes? Yes, okay. Which was a prereq. But it's sort of the same thing, right? Like we're looking to optimize, make our programs faster, more performant, right? Make better use of the resources that we have, right? And this is everywhere in computer science. I've yet to not see it in a field, right? So we're going to do something different that might be a little awkward, right? And I'd like to have, hear where y'all are at with this, right? So we're going to take a couple minutes. If y'all could, talk with folks around you, right? Maybe this is new, and, I don't know about any of this is, totally acceptable. Totally cool with that, right? But, if you had to answer, right, why would you say there's so much focus on efficiency in computer science, right? Does that focus make sense? Is there anything else we should focus on? 5 minutes. Does this feel okay? Yeah? Okay, cool. Let's chat. Okay, folks, are we good to come back? Good to come back. I would like more time. Good. 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 Okay, what do y'all think? Go for it.
We were talking about it was kind of hard for us to think of anything besides efficiency, I guess.
Sure.
We're just used to that, and it's like so many things can be reframed as efficiency.
Yeah.
It's like if we want to make this more accessible, it's like, okay, how fast can we get this to people?
Yeah. Right.
It was hard for us to think of anything besides reframing it as efficiency.
Okay, so efficiency is important. Lots of things could also exist, but like it's hard to not see those as efficiency. Okay, all the way back.
I'd say that I think maybe there's a focus on efficiency because that's what when computing was originally coming onto the scene. That's the purpose of computing is to make calculations more efficient. So that like paradigm just stuck into the
Sure. Yeah. So originally we had computers. One who computes is a person, right? And we have computers sort of replacing those, automating out those jobs. Other folks? Go for it.
Kind of what we said is if you want to build different tools that don't focus on efficiency, you still need tools to start out with. Like when you make, a language, you got to bootstrap a compiler. It's like you're bootstrapping better things. And the thing you start with has to be like as top-notch as possible.
So we're always building on top of something, right? And that something's already been made, maybe in this paradigm, right? We need it to be as fast as possible so we can build something that's not, flub, right? Yeah? Yeah?
We kind of focus on like, does this focus make sense to you?
Sure.
And we said in the sense that humans, all of our time are limited.
Yeah.
If you're trying to research something, you don't really have 200 years to wait for the computer to finish.
Yeah.
In terms of efficiency or like performance efficiency, it does make sense for it to be fast.
Yeah. So we as humans are fundamentally in an efficient paradigm. We only have so much time and then we die, right? Sorry. It's good to know, right? And so like it makes sense to have the tools that we're using sort of reflect that as well, right? Other folks want to contribute? Go for it.
Just from a personal perspective, I hate lag. Like, I'm going to want a faster computer.
We hate lag. We got to go fast. Cool. Other folks? Yeah?
I think it doesn't make a lot of sense to frame it as is efficiency bad or good? Because I think Ego said its efficiency could be applied to anything.
Sure.
So I guess it's not should we be efficient or not? It's on what should we be efficient?
Yeah. Cool. So less about efficiency is good or bad and more about what we're optimizing along. Yeah? Yeah?
Kind of for the last question, we were talking about how one thing we should focus on is what if we're sacrificing anything or what we're sacrificing in the name of efficiency.
Yeah.
Whether that's equity, fairness, or accessibility.
Yeah, right. So we do have other things in this space and we only can focus on so much at once and we should be cognizant of what we're necessarily giving up, right, if we're having this focus. Other thoughts to contribute, folks? This is awesome. This is lovely. Yeah.
We said that maybe one reason there's a lot of focus on efficiency is making money. The faster your computer is, the more tasks it's going to be able to do for you.
Yes.
So the less computers you need to buy, the better your computers are.
Yeah. We're in a broader economic context. Let's say. I won't put words and names on it, but we're in a broader economic context that has some incentives and some paradigms, right? Okay. Okay. Yeah.
Yeah, joining on the last point, efficiency boosts productivity, and that's kind of what, at least our society values a lot of productivity.
Yeah.
Efficiency and productivity go hand in hand.
They tend to, yeah. Yeah, but we can ask this, efficiency and productivity goes hand in hand, but we could ask, what else is there, right, besides what we produce? Cool. Okay, so just hold that, right? Hold the rumblings in your brain, yeah, if that's possible. If they leave, maybe invite them back, right? If they leave and they're gone for good, hey, that's okay. Maybe they'll come back again. But we're just gonna hold that for now, yeah? And we'll talk about caches. So y'all talked about this already, so we're already here, great, right? efficiency is a metric, right? And like, what do we do with metrics? We try to optimize along them, right? Like we pick a metric. We want to improve ourselves, our programs, our performances along that metric, right? Especially when your job or your funding depends on better performance, right? This is like, so Moore's law got thrown out early, right? Gordon Moore was just a VP at Intel, right? And he like looked at 2 points on a graph and he was like, yeah, it looks like performance is doubling. We should keep that speed, right? And that's where it came from. Like, it's not a law, right? It's just like some dudes rambling, like extrapolating from 2 points on a graph, right? There's more going on here in context. And so if we have metrics, right, like sometimes strange incentives emerge, right? And some of what y'all were saying was kind of hinting to this, right? Like if we're trying to minimize the number of bugs on a dashboard, right? Like we have some like SEO, whatever, like, how many bugs do we have, bug tracker, right? Does it count if we make the bugs invisible, right? Like if we're trying to like make something faster for a demo in a week, right? Or like ship something quickly, right? Like how is that going to affect performance at scale, right? And this is like, we're still in computing context, right? This is like, we're not even getting to the fancy society stuff yet, right? In the same, we could ask about caches, right? We want to minimize our average memory access time, right? And like, what if we add more memory accesses that will hit, right? Doesn't matter if they're like doing anything useful or not. Let's just add another loop iteration, right? We've got a whole sequence of hits. We'll just hit throughout our cache, right? AMAT goes down, right? GG, no V. Anyway. And so this is the piece, right? Like, what we define as success, right, is defined by the metrics that we use, right? So, like, hypothetically, right, like, let's say we choose performance, right? Performance per program, performance per program set, right? This is benchmarks for the computer scientists and the computer architects or whatever, right? Like, we'll measure some existing performance, right? We'll come up with a bunch of optimizations that would improve those metrics, right? We'll select a few to build into the next version of whatever we're making, right? Whoop. I don't like slides. Okay. And then we'll be done, right? We'll like, measure again, right? We'll see where we're at. We'll go from there, right? But we could do something else, right? We could do like, let's say we chose like profit per year, right? As many large corporate entities do, right? Or stock price, right? That's our metric that we want to optimize along. We want to keep improving along that metric, right? If success means earning more profits than last year, right? Like, we might reduce expenses. We might cut staff. We might try to like sell more things or more fancy things, right? We might make people pay monthly for things they could get for free, hypothetically, of course. We might, try to increase advertising revenue and do all sorts of like nefarious, I think is my nicest word, nefarious things, right? Things not necessarily like within the common good, but they'll optimize along the metric that we have, right? And so we'd be more successful, right? Because of the metrics that we chose. And we can go further, right? So I'm using minoritized here to talk about I did not choose the oppression that I experience, right? The society that I live in broadly imposes it upon me, right? So I don't consider myself like a minority, right? Minoritized, right? Just distinction. So we could say like we want more folks that have been minoritized by society to be like within computing, right? So what might we do, right? Like we have to define our terms, right? Like what do we mean by success here? What do we mean by participation? Who do we mean by minoritized, right? Like how might those optimizations occur, right? And then like the participation piece, especially in computer science, is nefarious, right? Because like we've measured participation in CS by like the people that took intro, right? And then left, or the people that passed intro and then left because, they took it with some professor that I won't name. So, I've love for lots of people. I really try to hold that, but goodness. And so this is the piece, right? Like regardless of what we end up building, right? It could be like, the computers that we make, it could be like the structures, the houses of computings that we live within, right? It could be like the ways that we bind ourselves, right? The ways that we structure and schedule our time, right? The way that we define success shapes that system, right? The metrics that we choose, right, shapes the system that we create. Cool. there's more than performance. We could talk about other things, right? And this is like the first point we'll kind of end on, right? Like metrics are a heading, right? They're a way of saying like north is about that way, right? We want to head about that way, right? But if we don't reconsider our metrics from time to time, we might end up in some strange spaces. Okay, does this feel okay so far? Okay, cool. Questions on this so far? Hot, spicy takes. I welcome them. I have many of them myself. Yeah?
So it's like the whole idea of like fostering diversity in like computer science is one way to like try to combat like the minoritization of people and ideas, right?
Mm.
But can't you just define that as like the thing you want to be efficient?
Yeah, so like the metrics I like to choose are like I don't want systemic oppression, right? Like I want to be able to breathe freely, right? I would love that to be like, it's hard to measure that, right? And like we have some good metrics. I mean, we can look at like incarcerated people per capita and get a good idea of like, how well we're doing along that sense, right? But it's there, so, a rightful tension, right? Of like, some things are easy to measure, right? Some things are much harder to measure, right? But like we do end up like, we have to pick a metric at some point, right? Yeah.
One thing I was just thinking is like, a reason you might want to pick efficiency is because there are different metrics you can pick, and so you can seek out when you're developing like a technology or a company or whatever.
Yeah.
And there are things that are more directly related to the work you can do. So like the work you can do when you're making a computer is to make the computer fast.
Right.
You can also like target your computer for a societal outcome, but that might be a lot harder for you yourself.
Yeah. So like it's a scoping question, right? Like I would love my research to be like, let's make everything better for everyone everywhere. And like I won't even start like a single step of that work unless I can scope it down to something that's reasonable. Right? And so efficiency kind of makes sense because it has this nice well-defined scope, right? It's not necessarily like everyone everywhere, right? It's within the scope of what we're already working on. Other thoughts? Okay, let's keep going. So back to context, right? Let's talk about caches, right? So, mentioned in the back, right? Computing historically has prioritized performance, right? Like, mind you, we can pick other metrics, right? But we optimize for the common case, right? And so I don't know if y'all have had experience with like the best optimization strategies in computer science, right? But this was my experiences of them, right? Like if we want to make things fast, we should optimize the common case because the common case is happening most often. And so if we can optimize the common case, right, we'll have a faster program. This is like a good foundational optimization strategy in computer science. And we had that with caches, right? Like common case programs exhibit locality, right? Common case programs look like this, right? We're summing a 2D array, right? We're traversing along the row major order that we talked about. We have spatial locality, we have temporal locality, right? When we defined locality, when we were making caches, we defined it based on the existing set of programs, right? Like that's how we got to this point, is that like, whoever in whatever company, right, looked around to all these different programs and said, hey, generally we see things like this, right? On average, we see things like this, right? So let's try to optimize for things like this. Let's try to make this fast. And Sam did this thing, right, that happens a lot in computer science, right? Like, programs exhibit good and bad locality, right? But like Sam had this piece, he was like, it's fun because he's not here. He also okayed this, so that's fine. Like, this is bad code, right? Bad, right? Like, this is code that does not exhibit good locality, right? It's unoptimal, right? It's suboptimal. Like, this code exhibits good locality, right? This is good code, right? And there's this like this piece, right? Like, because we surveyed programs, right? We got caches out of that survey. We're optimizing for the common case. We have this like morality judgment here, right? of like how well things fit an existing structure. Yeah? We have bad code that doesn't fit it. We have good code that fits it. There you can see the thread. And so like we can view this way, right? Like we're using efficiency to measure success, right? We've got AMAT, whatever, right? Like what optimizations might we choose, right? We might choose faster processors. We might choose like, more complex hardware in service of better performance. And we might build something, this specialized, expensive piece of hardware that's a huge source of complexity and bugs that regularly confuses 351 students, right? And also causes like massive, like multi-million-dollar like software, hardware failures, right? You can go look at Meltdown and why it's bad. And so our choice of metric affected what we built, right? We wanted efficiency, we optimized the common case, right? The common case code was locality, so we built caches, right? And then this last piece, right? We value judged programs, right? Our good code and our bad code, based on their ability to fit within that structure. Okay. Good. I have some rumblies about this. This is bad. Mara, what are you doing? This is a great time for questions also. There'll be a couple of them. I'm going to turn myself down. Still okay? Nods? Yeah.
I'm just a little confused because it seems like a lot of the issues that like obviously go into like affect like algorithm programming are like very contextual.
Sure.
Like I think a lot of the reason that like accessibility to like programming courses is like a reflection of greater like systems that are like present in like other things in addition to programming.
Yeah.
But, like within programming, it seems kind of hard to change that context. Like looking at like analyzing a piece of code, like how could we do that with respecting all those contexts rather than just saying like every time access or whatever. Does that make sense?
This is like, so we have, can you still hear me also? I turned myself down. Still okay? Okay, cool. This is like, we have the CS space, right? And then we have like the messy social context space, right? And those do not interact well. Yeah?
Yeah, it's like kind of hard to see like how like because when we're looking at code, like a lot of feel like of my learning in CS has been like thinking algorithmically, like how can
Yeah.
I do this better?
Yeah.
Like that's what makes CS like one of the things that makes it different from like other subjects.
Sure.
So, like I don't know.
Yeah. You're touching on a very big tension that we'll come to in later slides. Okay. Did I see a question around here? No? Okay. Yeah.
So are you kind of like saying, which kind of makes sense to me, is like CS has been like built on like older and older like innovation to the point we are now. So like all of our code now relies on like fundamentals and decisions that were made like 40 or 50 years ago, right? Where we just assume like having a cache that prioritizes like whatever like prioritizing like temporal locality, right? Like is a good thing. Is that kind of what you're saying? Or like it might be good maybe to like look into those decisions and see if like maybe we could optimize caches differently.
Yeah, I think I'm trying to voice here, and this is like when we'll get to it in a few slides, like the decisions that we've made are historic, right? Those historic decisions were made within a given context, right? And we should examine that context when we build more things, right? Lest we replicate that context in a space that causes harm, right? The big reveal at the end of this isn't like caches are bad, right? Caches like we can do any of this because of caches, right? Like we can present in this fancy auditorium. Other questions? Yeah.
So the idea that like we would want to prioritize like more readable or more human-friendly code for efficiency, like that makes a lot of sense to me. But it feels like at a really like this low level, it seems like it makes a lot of sense to value efficiency because these systems are created.
Yeah. So like again, I'm not like y'all were mentioning this earlier, like I'm not knocking efficiency and all, like efficiency is okay, right? Like we're efficient, we have to be efficient people, we only have so much time and then we die. Remember that? Yeah. And so like, I'm not saying bad in all contexts, right? I'm saying this is an unexamined norm, right? That like surfaces in all these places. We're about to get to a fun example, I promise, right? That like in caches, does efficiency make sense? Probably, right? But like what happens when we apply the same paradigm somewhere else? We good to keep going? Okay. Okay. So here we go, we have an example, okay? So like, let's take this idea elsewhere in computing, right? Let's go on a trip, like cue the airplane noises, right? So like, we'll head to the airport. This is like fun, whatever. We'll head to the airport, right? But before we get to our gate, right? Before we get on our plane, we have to go through this mess, right? That like and more specifically, we have to go through this machine, right? Like folks are familiar, you go like this, right? It's weirdly uncomfortable for about 3 seconds and then you're done, right? Okay. What happens when I go through this machine, right? Like, so it was fine for a while, right? And then I realized some things about myself and made some changes, and here we are, right? Like, this is what happens. So this happened to me first when I was flying. My hometown is Rochester, New York, right? It's fine. Whatever. And I was going from there to Seattle. I was home for my sister's wedding, right? And I went through the scanner, and I went like this, and I was like, oh, it's going to be fine like every other time, right? And the attendant, the agent, I guess is the word, right, pointed me towards the screen and said, like, do you see what came up here, right? And I think I said, like, I'm trans, you scanned me wrong, right? And they responded, I have to scan the way that you're presenting, right? And so, I got a pat down. It wasn't great. I didn't get detained, which was great, right? That's happened to some other trans folks. But like, what's going on here, right? For folks that are maybe unfamiliar, right? So the TSA in the United States, right? They choose metrics, right, that are important to them when deciding who they award government contracts to, right? Like, who gets to build all the scanners that make you go like this, right? Is dependent on like who does the best job along some metric that the TSA chooses, right? And they might choose efficiency, right? Like how many passengers can we get through as quickly as possible, right? They might choose like false negatives, right? Like how many bombs were there that we didn't detect, right? Obviously the highest priority, right? The contractors will build systems to succeed along these metrics, right? And in this case, right, like we'll build machine learning models, right, based on lots and lots of bodies, right? So we can figure out like which bodies have anomalies on them, right, that might be threats. Here, right, there's predictable, like, we look at, most bodies, right? There's predictable variation along common case bodies, right? And this is like bodies of cisgendered men and cisgendered women, right? So some bodies, most bodies either have a lack of chest tissue and external genitalia, right? Or, right, chest tissue and internal genitalia, right? Most bodies, common case bodies, right? And so they were like, okay, we've got this predictable variation. Let's build 2 models, right? One for men, one for women, right? And we'll make a blue button and a pink button. I think that's just, freaking icing, right? And the protocol here is like TSA agents will clock travelers, right? Clocking, if you're unfamiliar, that's like assuming a gender identity based on a presentation, right? Getting clocked, super fun. So TSA agents will clock travelers, choose a button, and then clear alarms as necessary, right? So this is fun, right? Like, I presented more femme that day. I think I was wearing a soft sweater and a bra. For anyone that's a victim blame based on what I was wearing, we can do that. I got pink buttoned, right? Actually, on a point like that, I've heard from other folks that the clocking method that the TSA uses is women always wear bras, right? And that's the way that we go through. And like, okay, so I got pink buttoned, right? Super fun. My body, I love my body. It's happily an edge case, right? And I'll take a pat down over being detained, but I'd rather not be outed every single time I fly, right? With like a picture that looks like that, right? For all travelers to see. And really rather not my body be labeled as a threat, right? Like, I'm not a common case, right? but like a threat seems a bit harsh, no? And so this is the piece, right? Like we optimized for the common case, right? At the expense of edge case performance. Hi, it's me. I am the bad locality code here, right? Right. And so this is like, we can see maybe a parallel here, right? And so again, like caches, I'm not saying caches are bad, right? I can present to you in person with Keynote and a computer, right? Because we have caches, right? But we wanted efficiency, right? And so we optimized for the common case, right? And the common case was cisgendered bodies here, right? So the machine learning models that existed, right, were built for cisgendered bodies, right? And they built binary gendered models, right? And then quite literally, like bodies were value judged based on their ability to fit within the structure that was created, right? Does this feel okay? Do we see the parallels to caches? Okay, any questions? Wonderful time for pushback if you have it. I know it's not fun to do it in a public forum, but I'll take it. All good? Okay. Well, this might be our whole lecture. That'll be fun. So, also, there was a buffer lecture at the end of the course, right, that we weren't sure what we were going to do with. We had some extra space, right, and so this might just be that. We're not like cutting existing content to make this fit. And so this is my piece, right? Like humans are incredibly complex and diverse, right? And like let's just go along like LGBTQ folks, right? Like, as polled by Gallup 5%, right? Among Gen Zers, like 16%, y'all are doing great, right? Excellent work. But like if we broaden that, right, away from like the alphabet soup that exists into like any non-normative gender, any non-normative sexuality, sexual preference, relationship, right? Like most people don't fit, right? Most people don't fit all the structures that exist, right? We can't bind our bodies in that way, right? And like, the intersection that we have, the intersection of normativity doesn't really fit anyone. And this is one of my favorite charts, right? And so this is like an intersections of privilege chart, right? That we can talk about, right? And there's lots and lots of different kinds of privilege. There's lots and lots of different spaces, right? Do I have a mouse pointer that y'all can see? Definitely not, right? Let's go real easy, right? Like genderism, right? So we can follow the spectrum, like folks that present male and identify male and are masculine, right? Folks that present feminine and identify as feminine and present feminine, right? Let's do the dance even, right? As opposed to folks that are gender deviant, right? I guess that's me. Right? And we have like lots and lots of spaces here, lots and lots of intersections, right? But like, there are some folks that fit every intersection of normativity. They do exist. I've met them and they confuse me, right? But most people aren't like that, right? And like, when we're optimizing for the common case in this way, right? Like we're optimizing for, in general, right, like everyone that's on the upper half of this graph, right? And this graph doesn't include everything. This doesn't include like neurodiversity, ability to cope with trauma, financial stability, parent status, whether they're alive, dead, and divorced, right? Like whether you grew up in urban settings or rural settings. Like there's lots. This was 96, y'all. Like we have more space here. But this is like the messy social context, yeah? Like the messy social context of the world that we exist, and like CS is a part of that, right? I'm stealing slides from my advisor. You can go watch her keynote. It's great. This is Respect is a conference. She gave a keynote in 2021. You just snapshot the slides. It's great. We know that CS is part of the world, right? Like we are a part of that social context, that mess, right? But CS sees itself as separate, right? And this is the issue here, right? And so like, I'm fine with saying like, caches optimized for efficiency and that's fine, right? And I'm not okay saying that like CS is segregated from the rest of the world and does not need to consider anything that's in this mess, right? Because inevitably we build things that interact with it, right? We built like, multi-trillion-dollar companies, right? Maybe I have the numbers wrong. That like are deep in this mess, right? That are shaping worlds in this mess, right? And it's not just like it's intellectual segregation, right? Like CS has a tendency to, right, extract away the social context, right? Reduce it to some, binary gendered form, right? Neutralize, like necessary social context and say, that's political, that's not part of computer science, right? Like some professors I won't name. We'll erase diversity through this normalization, through optimizing for the common case, right? And we'll automate out people's jobs and their unpredictable decisions in favor of something that's controlled, that's simple, right? And this talk goes much further than I will here. But, right, how are we? Oh, we're fine. Caches don't interface with people, right? And I'll happily say that, right? I'm not upset that we have caches that optimized for efficiency. I think it made sense, right? But, right, as technologists, as people that have the most ubiquitous trade in the world, right, at their disposal, right, we take those values and we put them everywhere, right, outside of caches into things that make you go like this. The values underpinning caches aren't, and also caches aren't entirely neutral, right? If you change your name on Google Drive, it will continue to dead name you on everyone's machine until everyone quits their browser and resets it, right? Because of caching, right? It's not always so simple to optimize for the common case. Right? I think Sam said locality is what we have control over, right? With the implication that we should always be writing local code, right? And I'm like, yeah, we should write local code because we do have caches, but that's kind of a practice of training yourself to be bound within a structure that's been made not necessarily on your behalf. And yeah, I don't know, right? Maybe we consider that one just a little bit more, right? A second of this, right? Turning over, right? Questions? Feels okay? Okay. So I'll soapbox for a second. I had a teacher in high school that went like this. It's jumping on the soapbox, right? Let me preach. You have incredible power and access, right? You are trained and you can do frickin' anything with the skills that you have, right? You don't have to go work at if you want to work at Microsoft, great. If you want to work at Amazon, great, right? But know it and want it for yourself, right? Don't do it because the frickin' auditorium is named this, right? I mean, it's right there on the wall, right? It's hard to not mention. But if you want to build Amazon's AWS, if you're excited about that, if you want your work to serve I don't know, Jeff Bezos's balding cream, right? Great, go work at Amazon, right? Work wherever you want, right? If that's what you're excited about, if that fills you with joy and fervor and makes you want to live in a better world, I say go for it, right? That's fine. Or if you have 200, I've talked with folks, 200K in student loan debt, and you just want to pay it off, and you want a job that pays you, hey, fine, right? Just know what you want for you, right? That's all I ask. And try to consider what you're building and who you're building it for, and what you're considering, what you're holding is important while you're building it. Okay. Off the soapbox. Okay.